LitSearch is a retrieval benchmark comprising 597 realistic literature search queries about recent ML and NLP papers. It's constructed using a combination of questions generated by GPT-4 based on paragraphs containing inline citations from research papers and questions about recently published papers, manually written by their authors. All LitSearch questions were manually examined or edited by experts to ensure high quality. The benchmark is unique in its challenging nature, requiring deep understanding and reasoning over entire articles, with an average document length significantly longer than most existing retrieval benchmarks. We conduct extensive experiments on both state-of-the-art retrieval models and re-ranking with large language models, LLMs. The best dense retrieval model, GRIT-LM, achieves an average recall at 5 of 74.8%, beating BM25 by 24.8%. The recall at 5 of GRIT-LM is further improved by 4.4% with GPT-4 re-ranking. Commercial search engines and research tools like Google Search perform poorly on this task, only achieving an average recall at 5 of 42.8% at most. The authors of this paper present a new dataset called LitSearch, which is designed to evaluate the performance of literature search systems in retrieving relevant academic papers based on complex queries. The dataset consists of 597 questions, with 351 in the inline citation subset and 246 in the author-written subset. The questions were collected from various sources, including ACL and ICLR conferences, and were manually filtered to ensure high quality. The authors also provide detailed statistics for the LitSearch dataset, including the number of questions, average question length, and average word overlap between the question and target papers. They find that author-written questions are shorter and have a higher word overlap rate with the target papers compared to inline citation questions. The authors compare the performance of different retrieval systems on the LitSearch benchmark, including classic BM25 algorithm and several state-of-the-art dense retrieval models such as GTR, Instructor, E5, and GRIT-LM. They also evaluate the performance of LLM-based re-ranking strategies using GPT-4. The results are reported in terms of recall at K for both broad and specific subsets of LitSearch. Overall, the paper presents a comprehensive evaluation of various literature search systems using the new LitSearch dataset. The findings provide insights into the strengths and limitations of different retrieval models and LLM-based re-ranking strategies, which can help researchers improve the efficiency and accuracy of their literature search processes. The research paper discusses the performance of various retrieval models on LitSearch, a dataset comprising titles, abstracts, and full texts of papers. The authors evaluate the model's ability to retrieve relevant papers based on question types, including broad and specific questions, and question quality. They observe that models like GRIT-LM7B outperform BM25 and other baselines, especially on specific questions. Re-ranking methods, such as GPT-4 re-ranking, also show improvements over the base retrieval performance. Interestingly, including more paper content does not consistently improve retrieval performance, except for some cases with author-written broad questions. The study highlights the challenges of retrieving relevant papers, especially for specific and high-quality questions, and suggests that the current retrieval models are robust against exploiting similar citation mentions. The research paper discusses the LitSearch benchmark, a novel retrieval benchmark consisting of 597 manually curated literature search questions. It includes both inline citation and author-written questions, ensuring a comprehensive evaluation for citation recommendation systems. The authors conduct extensive experiments with various retrieval models, such as BM25, state-of-the-art embedding models, and LLM re-ranking. The results show that LitSearch can differentiate retriever models better than existing benchmarks, highlighting its potential for evaluating recent advancements in embedding models. Additionally, the paper compares the performance of search engines like Google Search, Google Scholar, and Elicit on a random subset of questions, demonstrating their poor performance compared to the dense retrieval models. The authors also discuss the importance of considering the source of inline citation questions, as they can affect model performance differently. Overall, The paper emphasizes the significance of LitSearch as a new benchmark for evaluating citation recommendation systems and their ability to address real-world scientific literature search tasks. The authors discuss the limitations of their LitSearch dataset, a benchmark for literature search tasks. Despite manual examination, some questions may be out of distribution or too easy due to high overlap with target papers. The author-written questions are easier than expected, highlighting the difficulty of writing challenging literature search questions even for experienced researchers. The evaluation is not exhaustive, and more sophisticated retrieval or re-ranking systems are not considered. The research focuses primarily on English questions and research papers, which may introduce biases. The authors acknowledge the contributions of various individuals and organizations, including the Princeton NLP Group and the authors of ACL 2023 and ICLR 2024 papers who contributed questions to LitSearch. They also acknowledge the support of an NSF Career Award and Microsoft Azure credits. The paper cites various references related to language models, citation recommendation, and information retrieval. These references include works on SciBERT, LLM2Vec, Spectre, SimCSE, and Colbert, among others. The authors draw on these works to contextualize their research and highlight the novelty of their approach. The LitSearch dataset is designed to evaluate the performance of literature search systems. The authors demonstrate the effectiveness of their approach by comparing it to existing retrieval benchmarks and commercial search engines like Google. They show that LitSearch better highlights the different performance of retrieval systems. The ethics statement ensures that the research artifact, LitSearch, is manually inspected and free of unsafe or inappropriate content. However, the authors acknowledge potential biases in the dataset generation process, such as the overrepresentation of highly cited papers. Overall, the authors provide a comprehensive overview of their LitSearch dataset and its limitations, highlighting the need for further research in this area. They also acknowledge the contributions of others and the support of various organizations, demonstrating the collaborative nature of research in natural language processing and information retrieval. The research paper discusses the concept of instruction fine-tuned text embeddings, focusing on their versatility in various tasks. It highlights the work of several authors who have contributed to this field, including Hongjin Su and colleagues, who introduced the idea of one embedder for any task. The paper also references the work of Weiwei Sun and others on ChatGPT's search capabilities and its potential as a re-ranking agent. Additionally, it mentions the referral augmentation for zero-shot information retrieval by Michael Tang and colleagues. The authors emphasize the importance of benchmarks like BEIR for evaluating information retrieval models. The paper concludes by acknowledging the contributions of numerous researchers in the field, including those who provided author-written questions for the ACL 2023 and ICLR 2024 papers. The research paper presents a novel approach to constructing a challenging retrieval benchmark, leveraging the ACL anthology and ICLR papers extracted from S2ORC. This is achieved by identifying ACL anthology papers and ICLR papers within S2ORC through metadata and title matching techniques. The authors utilize various dense retrievers, including GTRT5 Large, Instructor XL, E5 Large of 2, and Grit LM7B, which are fine-tuned with specific instructions for encoding queries and papers. The authors also describe their efforts in collecting author-written literature search questions via email and Google Forms. They provide detailed guidelines for authors to create realistic, specific, and challenging queries that would be difficult for state-of-the-art retrievers to answer. These queries are designed to test the ability of retrieval models to understand complex research questions and retrieve relevant papers accordingly. The paper includes tables detailing the Hugging Face checkpoints used for each dense retriever, as well as the prompts and additional statistics about LitSearch. It also showcases the emailed template sent to ICLR 2024 and ACL 2023 authors for collecting their contributions, along with the instructions provided in the Google Forms for creating challenging queries. Overall, this work aims to advance the field of information retrieval by developing a more challenging benchmark that can effectively evaluate the capabilities of large language models. By leveraging the expertise of authors in creating realistic and challenging queries, The authors hope to create a valuable resource for the research community. The research discusses the motivations behind ad text generation, particularly for product descriptions. It highlights the utility for improving the seller experience in e-commerce services, reducing manual data entry, and potentially enhancing sales through better descriptions. The study also emphasizes the understudied nature of ad text generation as a proxy for persuasive text generation. The authors cite various papers that explore persuasive text generation, including studies on ranking argumentative comments, discourse relations, and the persuasive effect of style in news editorial argumentation. They also mentioned papers focused on generating persuasive text for specific domains like fashion and product descriptions. The research concludes by highlighting the need for further studies in this area, particularly in terms of quantifying persuasive text and its applications in product development.